Hello guys. Today is our second day, second lesson of our theory class 2027. Today last week we discussed about basic things and introduction and also about physical quantities and units in first lesson. Today we continue that. Before starting the lesson today, I have given you some homework, right, in your tube. So first I am going to discuss that. So this is a simple homework I have given to you, that is about mathematical calculations needed for physics. So first we discuss that, right. So you can turn into page number 10 in our theory tube, right. So we discuss that now, right. So this is about scientific notation. You know that when we write a number in scientific notation, there we have only one number in front of that decimal point, right. Therefore, now in this number we have decimal point here, right. So we need to take it to here, right. So there we have we can count that 10 and 11 positions. So it is going from 11 positions. Therefore, we can write 1.5 when it comes to here. 1.5 into 10 to the power 11. Need to write the given unit also. Then in this case, that is moving towards opposite direction 4. Therefore, 2.54 into 10 to the power opposite direction, therefore minus 4. Right. So this type of additions, when we are doing this type of additions, it is better writing them in line, right. Then 2, 3, 2.35 need we need to add it at this one. So we write decimal place in line. Then 3.4 here. We don't have one here, number here, therefore we can write 0. So this is 3.40, right. Then we have, can add them. This is the answer, 5.75 kilograms. So Uday, you can correct your answers all about the hariyak dag and planning. Right. Then we move to next one. There we have subtraction. Then 8.423 minus 2.52. So we can write 0 here. We are not, if numbers are not given at the end of the number, we can write 0. So you know that. Then we need to subtract here, right? Here that is 3, 0. We can take 1 from here. Then 9. Here we have 7. Then this is 5, right? So the answer is 5.903. Again we need to write the unit, right? If a unit is given, don't forget to write that because that is compulsory, right? Then here same base is there, so that power is added when we multiply them, right? Then L to the power 2 plus 1, that is 3, and here M to the power plus 3 minus 2, then that is 1, right? Then here we have L to the power 1, right? Then we can simplify this, right? L to the power 2, and in this case we can take that to numerator, right? X to the power 3, L to the power, x to the power 3, then x to the power plus 2, that becomes plus 2, then 3 plus 2, that is x to the power 5. Then here we have a bracket, right? So when we have a bracket in normal simplifications, what we do, we multiply with the numbers in outside, right? So here we have a power, right? So outside power, we have power outside from the bracket. Therefore, we need to multiply those outside and inside powers, right? Then 2 into 3, that means m to the power 6. And here 2 into minus 2, therefore n to the power minus 4. And in this case, we have two powers inside, so both of them should be multiplied with this. Then m to the power 3 into 3, that is 9, and minus 2 into 3, that is minus 6. Likewise. Right. Then next one, when we consider square, right? Here we have inside we have powers for both of them, right? Here 3 to the power 1, not mentioned means that is the power, that power is 1. So we need to multiply both of them, right? Don't forget this one. Then 3 to the power 2, right? Then 8 into 2, 10 to the power 16, right? So we can write that 9 into 10 to the power 16. And here also we need to multiply all the powers inside with outside power, right? Then here we have m to the power 2 and 3 to the power 2 means that is 6, right? Then next one, here also we have power 2 into 2, m to the power 6 divided by 2 into 3, n to the power 6, right? And this one, here we have this is the decimal number, so here we have power 1 for that, right? Then we need to multiply both of them with that outside power. Then 2.6 into the power 2 multiplied by minus 2 multiplied by 2, that means 10 to the power minus 4, right? So that value, that is 6.76. You can't use calculators, right? You need to do it, right? Then because you are not allowed to use calculators in A-levels, keep that in mind today. Therefore that's why we again and again discuss this type of calculations, right? So always try to maintain your ability of simplifying, simplifying and solving problem with numerical values, right? So therefore these things very important, because you are not given a calculating exam, right? Then 10 to the power minus 4, this is the final answer, right? Then here, so this is something similar to the problem we discussed earlier. So here common, we have a common factor, right? 10 to the power 4 there, 10 to the power 3 there. So 10 to the power 4 means that is we can write 10 to the power 3 into 10, right? Then 10 to the power 3 is a common factor. Then 4.0 into we can write 10 to the power 3 is a common factor. Then 4.0 into 10 plus 2.5, here 10 to the power 3, that is a common factor. So you can calculate that. This is kilograms. So this is 4 into 10 means 40. 40 plus 2.5 means 42.5 into 10 to the power 3 kilograms, right? Okay, right. This one also a similar one, we need to subtract that. So 0th power we will discuss here now, not about that one. This is not about that. Then here also we have common factor 10 to the power 4, so we can take it out from the bracket, and 6.35 minus 2.1, and here we have two decimal places, therefore we can write two decimal places like this. Then 6.35 minus 2.10, write them in line decimal point. Then 5 minus 0, that is 5, 3 minus 1, that is 2, and 6 minus 2, that is 4. So final answer 4.25 into 10 to the power 4 is there, right? Okay. And also before this one, there you have dotted lines to write about zeroth power. Right now we know that zeroth power of any number, right, that is 0. Sorry, that is 1. Okay. Okay, write down zeroth power of any number. Zeroth power of any number is 1. Zeroth power of any number is 1. Right, then they write down these examples. Now if we write 2 to the power 0, that is 1. We can write x to the power 0, that is 1. We can write 27 to the power 0, that is 1. Any number 0th power is having answer 1, right? Okay, in there in Bioniva, right? Okay, then we move to next one. Right, then today next one we need to find v. So we can subject v, we can take that to other side. 1 over v equals 1 over 3, that become minus 1 over 4. Then we can have common factor, right? We can multiply both numerator and denominator by 4 and here by 3. Then 12 is there as the denominator. Then 4 minus 3, that is 1 over 12, that is equal to 1 over v. So we need to find 12, therefore we can cross multiply that. Then v is equal to 12, right? And in next one it is given values. V is equal to 5, m is equal to 1. V equals 5, m equals 1. So we need to find t. Now it is inside at the square root, therefore we can remove square root first. Therefore we need to consider square of both sides, v square. Then when we consider square of this side, square root, without square root we can write t over capital M, right? Then we need to find t. V squared into capital M equals t. So v, that is 5 squared, into m, that is 1, right? Then 25 into 1, that means 25. Right, so those are about homework, right? First day ki homework about mathematical simplifications, right? So from now we continue our lesson. Now we discussed our topics in this tube, right? So now today we start from page number 3, right? Page number 3, you can write there in the tube, right? So topic: finding units of an unknown quantity of a given equation, right? Now when you are given an equation, so you need to know how to find units of a given physical quantity, right? So now we we have seen lot of equations in mathematics, in physics, right? So we can categorize them into two categories like this. Equations with only two terms and equations with more than two terms, right? So first write down on the dotted line. You can write down. There are lot of equations in mathematics and physics. There are a lot of equations in mathematics and physics. We can categorize them. We can categorize them according to number of terms. Number of terms. Right. Then I'll consider this equation f equals ma. Right now the terms are always separated by equal mark or with positive or negative signs, right? So here we have two terms there, right? Then this equation with two terms, right? So I'll write another one. S equals ut plus half at squared, right? In this equation we have three terms, right? So that is how we identify number of terms in given equation, right? Okay. Then write down example. This one two terms, right? And here three terms. Right. So the terms are separated by plus or minus or equal sign, right? So these are some examples. Now we discuss about equations with two terms only. So how to find unknown quantity, right? So you are given that subheading in the tube, right? Turning to next page. When the given equation has only two terms, right? Okay. So there you have dotted lines. Put there, write down. Okay, write down. First we need to subject the unknown quantity of given equation. First we need to subject the unknown quantity of given equation, right? What you need to do first? You need to subject unknown quantity of given equation with two terms, right? Okay, then we consider an example, question number 11. Right, you can answer for these questions with your note. Notebook answers. Right, question number 11. This one, it is telling about this equation f equals g m1 m2 over r square, right? So we need to find units of g, right? So what is the first thing then we need to do? We need to subject that, right? Therefore we can cross multiply others. Then g is equal to f into r squared divided by m1 into m2, right? So after that we can consider units. Right now, this is an equation about gravitation. Right, in final lessons you will know about these things. Right, just for now I'll tell that here we consider two masses. Any two masses, they have gravitational attraction force. Right, so that is F and distance between them R. So right, so they considering units, we can write so when we considering units of F, that is force. Force ke unit එක derived unit එක දාන්නත් පුළුවන්, newtons දාන්නත් පුළුවන්. Right now in this question they are not given answers. MCQ එකක් නෙවෙයි. MCQ එකේ නම් අපි answers දිහා බලලා we need to decide what to substitute here. Right, මෙතන අපි මොකද්ද දාන්නේ කියලා derived unit එක දානවද එහෙම නැත්නම් newtons SI unit එක දානවද කියලා. answers වල newtons තියෙනවා නම් අපි එතකොට newtons දැම්මම කමන්නේ නැහැ. answers වල newtons නැත්නම් fundamentals units නම් තියෙන්නේ. එහෙනම් අපි දාන්න ඕනේ derived unit එක. Right, but in this question it is not mentioned specially, therefore we can write anywhere any unit here. So I'll write SI unit of force newtons here. Right, one අනිත් එක ලිව්වා, derived unit ලිව්වා, ප්‍රශ්නයක් නැහැ. Both are correct. Right, then newtons into distance meter square, and these are masses kilogram into kilogram. Right, then right, newton meter square, here we have kilogram square. Right, so we can take that to numerator, kilogram minus 2, that is the power. Right, this is the answer. These are the units of G. Right, then for the question number 12, we need to find units of Y. So first thing, you know, we need to subject unknown quantity first. Then Y equals F into L divided by AX. Right, then we can consider units. Considering units, we can write units of Y. Right, now you can look at the answers. Right, okay, in the answers you can see newtons. Right, therefore no need to substitute derived unit for this one. Right, then we can write newtons. Now this is the initial length of the rod, so that is measured with meters, and cross section, you know the unit, meter square, and extended length also, that is a length, therefore meters. Then answer nm minus 2. Right, then question number 14. So we need to find units of K. Right, so there's a problem. What is it? Now it is inside square root. Right, then first of all we need to remove that square root. Right, then we can consider square of both sides. Right, then here that C becomes C squared, and we can write without square root. Right, K over D. We consider square of both sides. Then we can subject this. K equals C squared into D. Right, so considering units, we can write units of K. So this C means here, actually that is speed of light. So anyway, speed means, you know the unit, ms minus 1 squared into density, that is kilograms meter square. Right, then we can remove the bracket. When we are removing bracket, you know that we need to multiply all these powers, then that is m to the power 2, and this is s to the power minus 2 kilograms. M minus 3 is there, right? So we can write kilograms plus 2 minus 3 minus 1, and s minus 2 is there, right? So this is the answer. Right, next one, question number 15. So you are given equation equals HF. You need to find units of H. So we subject that E over F, right? So we can consider units. Now in that question it is given that E means energy, F means frequency, right? So we can write here units of H, that is equal to units of energy, that is joules, right? For frequency we know that SI unit is hertz, right? Then habai tiya koren balanda answers there, right? So you can see that we don't have hertz in any answers, right? එහෙනම් මොකක්ද දාන්න තියෙන්නේ? එහෙනම් දාන්නේ අපි derived unit එක, right? So I think you remember hertz, that is equal to derived unit s minus 1. So we can write here s minus 1. When we take that to denominator, that becomes s plus 1. No need to write that joule seconds. This is the answer. Right, then we move to question number 18. Right, so we need to consider units. Considering units, right? Half means that is just a numerical values, just numerical values, they don't have units. Then rho, that is density, we can write derived unit kilograms per cubic meters, right? Then multiplied by v, that is velocity, ms minus 1 square, right? Then kilograms m minus 3, right? Again you can remove the bracket, m to the power 2 s minus 2, right? Then here we have kilograms plus 2 minus 3 m minus 1, and here s minus 2. This is the final answer, right? ඔන්න ගණන් ටිකක් හැදුවා. So what was that topic? Now we are finding unknown units of unknown quantity of a given equation. So this is the method when that given equation has only two terms දෙකක් විතරක් තියෙද්දි, right? Then පුතේ yes, then we move to our next one, subheading B, when the given equation has more than two terms, right? Okay, turn into page number 5. Right, so can you tell me answer for this question? පොල් ගෙඩි දෙකයි දෙල් ගෙඩි තුනයි එකතු කරාම අහනවා කීයද කියලා. Yes, what you can tell? මේකට ආන්සර් එකක් කියන්න පුළුවන්ද අපිට? බෑ, right? පොල් ගෙඩි දෙකයි පොල් ගෙඩි තුනයි වුණා නම් මෙතන මට පොල් ගෙඩි පහයි කියලා ලියන්න පුළුවන්, right? So that is how an equation exists, right? Equation එකක් පවතින්නේ ඒ පද හැම එකම units මොකද වෙන්න ඕනේ? Same, right? So that is very important thing. Don't write this one, right? Okay, so we have subheading simple B in page number 5. So you have dotted lines right there. Write down. When we consider an accurate equation, all the terms have same units. All the terms have same unit. Right. So they highlight that all the terms have same units. Right. So we write some examples. We write an example. S equals ut plus half at squared. Sorry. So S means displacement. Right. You know that unit is m. So here how many terms are there? Make it a right. Here we have 3 terms. Right. Terms separate when a plus, minus or equal signs within විතරයි. Right. So we know unit of this one. Then other terms also should have same units. Right. මෙයාගේ u ගේ t ගේ මේ තියෙන units multiply කරලා ගත්තම finally we get that. Right. After multiplying units of acceleration and t square, we will have meters. Right. Okay. So copy down this example also. After that, move to question number 19. Right. So it is given that C is heat capacity. Right. So heat capacity unit. Pala tute game question again liver command heat capacity unit, that is joules per Kelvin. Right. Right. So alpha, beta, these are Greek letters. So we use them as symbols in physics. Right. Then here we have three terms in the equation. So this is C. It is having unit joules per Kelvin. So the other terms also should have same. Right. So we can find units of alpha. They are asking about units of beta. Right. So we can consider term number 3. Considering units of term 3. Right. We can write units of beta, right, into units of temperature to the power 3 equals joules per Kelvin. Right. Then we can cross multiply units of beta equals joules per Kelvin divided by T to the power 3. Right. Then now temperature, this is temperature, so the unit is Kelvin. Right. We can take that to numerator, jk minus 1 into k minus 3. Right. Then that is jk minus 4. This is the answer. Right. Okay. Now in this question you need to find units of beta. Beta විතරයි හොයන්න තියෙන්නේ. අපි alpha හොයමු, right? For that same question එක ළඟම ඉවරන තැන ලියන්න මෙහෙම. Write down. Find units of alpha also. Find units of alpha also. Right. Then we can consider term number 2. Right. Then units of alpha, units of t equals jk minus 1. Again same procedure, you have units of alpha equals jk minus 1 divided by Kelvin. Right. We can take that to numerator, jk minus 1 into k minus 1. So that is jk minus 2. Right. Okay, then 20th question also a similar question today. Try it at home. You are given answers also. Okay, even you take a ganang other even answers you can check them, right? So in question number 20 today, a physical quantity is given as C, that is not heat capacity, right? That is specific heat capacity. So underline that specific heat capacity. Now heat capacity and specific heat capacity, they are two, right? So there they write down unit question එක ගාම ලියා ගන්න specific heat capacity unit joules per kilogram per Kelvin, right? So you can using that you can find answers for the given question, right? So after that move to question number 24, right? So in this question today we need to find units of d1 over d2 ratio, right? Now we can find units d1 d2 units separately and divide, but it's getting time, right? Therefore we can follow this method. We can directly make that ratio in a term, right? Equation එක හැම term එකක්ම divide කරන්න පුළුවන් එකම number එකකින් එකම value එක. That is a rule, right? Then we can divide all these terms by d2, right? Then we can, after that we can make that ratio here, right? So here you can see we have f over d2 and d1 over d2 into a plus v over t, right? Now here we have the ratio that we need, right? එතකොට මේ බෙදන්නේ මොකෙන්ද කියලා බලන්න පුතේ. ඔයාලට ඕන රේෂියෝ එක මේක. ඒකේ ඩිනෝමිනේටර් එකේ තියෙන වැලියු එකකින් තමයි අපි මුළු equation එකම බෙදන්නේ, right? Okay, then here we have three separate terms, right? Then directly unit of any term is not given, but here we can find units how. That is unit of velocity ms minus 1 divided by units of seconds, right? So we can take that to numerator, ms minus 1 into s minus 1, that is ms minus 2, right? So that is the unit of that term, right? That means all the other terms should have same unit, right? ms minus 2 and here also ms minus 2, right? Now we can consider units of second term, right? I'll write there. Considering units of term 2, we can write d1 over d2 units into acceleration units, that is equal to ms minus 2. Then we can cross multiply this. Units of d1 over d2, that is equals ms minus 2 divided by units of acceleration, that is also ms minus 2. You can see that they cancel each other, then no units, right? So that is the answer. Right, question number 30, we need to find units of ratio k1 over k2. So here also we can divide this by k2. All the terms are divided by k2. Then here we have that ratio we need, right? Then f into t divided by k2 equals k1 over k2 into a plus v. Right, so these are the three terms we have. So we know units of v, that is ms minus 1, that is p, and all the other terms also have the unit ms minus 1. Right, then we can consider units of second one. Considering units of term 2, right, then we can write k1 over k2 units into units of acceleration, this is equal to ms minus 1. So we can cross multiply, then ms minus 1 divided by units of acceleration ms minus 2, right? So these are the units of k1 over k2. Then right here we have s minus 1, we can take that to numerator. S minus 1 is plus 2, plus 2 minus 1, that is plus 1, right? That means seconds. Second, that is the unit of time. So that is the answer, right? Right, then we move to our next topic. Turn into page number 9 in your tube, right? So definitions of physical quantities in word. Now there sometimes we are given uh, definition of physical quantities in word, then we need to find units of them, right? Okay, there you have space to write down. Sometimes definition of physical quantities, definition of physical quantities given in words, then we need to find units of that physical quantity. Then we need to find units of that physical quantity as follows. Right, so we have some points there. Roman number 1, write down. Okay, write down. First, underline the physical quantities. Underline the physical quantities given in definition. If there is the word unit, if there is the word unit, you will write per unit. If there is the word per unit, in front of that physical quantity, in front of that any physical quantity, we need to mention that physical quantity. We need to mention that physical quantity in denominator. Right, so we consider an example number 1. Write down. Write down. Displacement per unit time, displacement per unit time is defined as displacement per unit time is defined as velocity.
Nothing.
Right.
I'm sleeping.
So you can underline the physical quantities today. What are the physical quantities? First one, displacement. Then time is there, right? And velocity. So now, what is the quantity we define here? That is velocity, right? So we write the equation for velocity, right? And here it is given that per unit time. That means we have that per unit, that word in front of that physical quantity. Therefore, we write that in denominator, right? Time we write in denominator, right? Displacement, that is in numerator. Then we can consider units. Considering units, we can write units of velocity, that is equals meters divided by seconds, right? ms minus 1. Okay, then we move to second example. Write down number 2. Density is defined as mass per unit area. Right. So we can write the definition here also. First identify the physical quantities, right? Then we can write here, we define for density equals mass divided by mass per unit volume. Then therefore per unit volume we write that in denominator. So this is how we write. Then considering units, we can write units of density, units of mass kilograms divided by cubic meters. We can take that to numerator, kilograms per cubic meters. Right. So Bhute, you have questions in your tute, right? Especially this question, you need to do a similar one. Page number 6, question number 27, and also question number 26. Right. Then second thing regarding these definitions in word. So second one, number 2, Roman number 2. Right. Sometimes in definition, word definitions, we have the term rate. Rate means we need to divide by time always, right? If the word rate is given in definition, we need to divide by time. Okay, write down. If the word rate is given, if the word is given, if the word rate is given, if the word rate is given in the definition, we should divide by time. we should divide by time. Okay, underline or highlight that. The term rate is given, should divide by time. Right. We consider an example. Write down first example. Write down. Rate of change of distance. Rate of change of distance is defined as speed. Right. So we use that to define speed. Right. Then display distance is there, and there we have rate. Right. Rate of changing distance. Then rate means we need to divide by time. We can consider units. Considering units, we can write units of speed, distance unit meters, time seconds, then meters per second. Right, this is the answer. Okay, then second example, write down to the rate of doing work. Rate of doing work is defined as power. Right. So this definition is for power. Work in numerator. Rate of doing rate means need to divide by time. Right. Then considering units. We can write units of power, units of work, that is joules, and divide by seconds. We can take that to numerator. So that is the answer, or we can write SI unit watts. Right. Okay, copy down. Right, then we can move to next topic, page number 7. Prefixes of SI units. Right, now we are going to discuss about prefixes we use in SI units. Right, මේවා ඔයාලා පාවිච්චි කරලා තියෙනවද දන්නේ නැතුව වුණා prefixes. Right, for example, I'll give these micrometers, centimeters, kilometers, likewise. Right, so this is the SI unit today. This is the unit. In front of that we use this prefix. Right, so use of that prefix. Right, we use prefixes to represent a certain constant value, a numerical value. Right, okay, so you have a space there. After that topic bus space up, right, then write this. After writing this, you have dotted lines there, write down. We use a prefix in front of the unit always, to represent a constant numerical value. Mostly they are powers of 10. Mostly they are powers of 10. within brackets write down factors of 10. Factors of 10. Right. Then next line write down there. Following table shows usual prefixes used in our syllabus. Usual prefixes used in our syllabus. Right. Then you need to copy down this there. So there you have a space to draw that table. Okay. Right. So okay. So there is a pattern there. We can write that pattern. We can table ගොඩක් values තියෙනවා මේ pattern එකේ මැදම ලේසි විදිහට ඔයාලට කියලා දෙන්න. Right? So we can start with the noun value. You all know about kilo, right? So kilo means 1000. So when we write 10 to the power 1, after that number of zeros we take that as the power, right? So 1000 can 10 to the power 3, right? So this is 10 to the power 3. So larger values than kilo, so we they increase by 1000, right? 1000 වලින් වැඩි වෙවි යන්නේ 10 to the power 3 වලින් තමයි වැඩි වෙවි යන්නේ, right? So to just to remember the pattern, you are very familiar with that computer storage values, right? Kilobytes, after that megabytes, likewise. So same pattern we follow in physics also, right? Kilo, then mega, after that giga, tera and peta, right? Okay, then that is 10 to the power 6, 10 to the power 9, 10 to the power 12 and 10 to the power 15, right? Then when we consider small values, these all values are capital letters, right? Then smaller values, when we write them, first we discuss about centi, right? You know that how many centimeters for 1 meter. So we have 100 centimeters for 1 meter, right? එතකොට අපි කොහොමද meter එකක් centimeters කරන්නේ multiplied by 100. එතකොට අපි centimeter එකක් meter කරන්නේ we need to divide by 100, right? So that means we need to multiply by 10 to the power minus 2. 100 කියන්නේ zeros දෙකයි, right? Therefore we write here 10 to the power minus 2, and milli we have same pattern again, 10 to the power minus 3, micro 10 to the power minus 6, nano 10 to the power minus 9, pico 10 to the power minus 12, femto simple F 10 to the power minus 15, right? These are the mostly used values in our syllabus. So I'll give some additional values also after this, right? So copy down this table. Right, then today we move to next topic on the prefixes, page number 8. එතන තියෙනවා additional prefixes කියලා ඉඩක් තියලා තියෙනවා. ඒක දැම්ම ලියන්න එපා. First we move to the topic subheading removing a prefix. Okay, now when we removing a prefix today, we need to write the value, substitute the value of the prefix instead of that prefix or that symbol. Okay, write down. We need to substitute value, numerical value of the prefix, instead of given symbol of the prefix, right? So first example they write down convert 50 kilograms into grams. 50 kilograms into grams. Right. So put a highlight that. Insert the numerical value of the prefix instead of given symbol. Highlight that. Right. Now we need to convert into grams. Then we need to remove the prefix kilo. 50 instead of that we can write 10 to the power 3. Right. Then normally we write final answers in scientific notation. Marking scheme එකේ තේරවල ගොඩක් වෙලාවට තියෙන final answer එක නොතිබ්බා කියලා ප්‍රශ්නයක් නැහැ scientific notation තිබ්බා කියලා නොතිබ්බා කියලා ප්‍රශ්නයක් නැහැ but පුතේ අපි tape marking කරද්දි ගොඩක් අර අපිත් එහෙම අන්තිම හරිය papers ටක් ගාලා බලන්න යන එතකොට marking එකේ වගේ answers තියෙදි ඉතින් බලන්න ලේසි right ඉතින් දුවට කමන්නේ මුලින් ඉඳන් පුදුමකට කමන්නේ right then you can write 5.0 into 10 to the power 4 grams is the final answer. Right. Second question. Now 70 kilometers. We can write here 10 to the power 3. Then 7.0 into 10 to the power 4 meters. And next one 70. Now put here. The thing is, this is how we read this kilometer square. That means kilometer into kilometer, right? So 2 kilo values multiplying each other, right? Therefore, so we can write, we can have bracket there. When we remove the bracket, right, both of them will have same power. Then kilo squared and meter squared, right? Then 70 into, here we can write kilo 10 to the power 3 squared meter squared, right? So 70 into, that is 10 to the power 6, right? Now you can see that when kilo squared is there, kilometer squared is there, then we got the 10 to the power 6, not 10 to the power 3, right? Then final answer 10 to the power 7 meter square. Right, next one, that is kilometer cube 70, right? Similarly we can write that is kilo to the power 3, right? Then meter to the power 3, likewise 70, then kilo, that is 10 to the power 3 multiplied by that value when removing the bracket. So 70 into 10 to the power 9, right? You can see that here when it is cube, that is not 10 to the power 3, that is 10 to the power 9. Kilo into kilo into kilo, right? Then final answer 7.0 into 10 to the power 10 cubic meters. Right. Then last question we discuss. Question number 3. Right. 70, we know the value of centi, 10 to the power minus 2 meters. Right, then we can write here 7.0 into 10 to the power minus 2. Right. Right. 10 to the power minus 1, scientific notation. Right, then here 70, so that is, you know that centi square meter square. Centi square means 10 to the power minus 2 square meter square, right? And 70 into 10 to the power minus 4, right? Then 7.0 into 10 to the power minus 3. This is the final answer. And here, yes, now you can see centi square means 10 to the power minus 4 because that is centi into centi. Now cubic centimeters, that is centi into centi into centi, that means 10 to the power 2 into 10 to the power 2 into 10 to the power 2, that means 10 to the power 6, right? Then 70 into, we can write centi to the power 3 cubic meters, 10 to the power minus 2 into 3, right? Then cubic meters, 70 into 10 to the power minus 6, so 7.0 into 10 to the power minus 5, right? Then 7.0 into, right, this is the final answer, right? So this is the second lesson of our theory class today. So you have lot of homework questions regarding these things we covered today, right? So next day we discuss how to insert a prefix, right? ඔයාලා මේ tubes දෙක select කරගත්තේ නැත්නම් count එකකින් ඒක select කරගන්න, right? Then
see the lid.
right, then you have a lot of questions are there, right? So when you come to next class, 20th, we have our next class, 12:30 Sunday, right? Sunday 12:30, 20th of April, right? When you come into next class, please cover your notes and come, right? This is the complete recording of second day of the class, right? Okay, then we meet next Sunday. Then homework කරන්න අමතක කරන්න එපා, right? ඔයාලා දැනට අපි මේ cover කරපු කොටස් වලින් homework තියෙනවා මේක කරන්න. මේ homework book 1 එකේ මෙතන ඉඳන් මේ තියෙන questions ගොඩක් ඒවා වලට පුළුවන්. page number 1 2 3 you can do that questions, right? And also there you have from page number page number 5 you have past paper question collection, so you have answers also there at the end of the end of that questions. You are given answers also, so you can write the answers for the questions. Either make it dimensions වලින් ආපු questions උත් තියෙනවා, ඒව බලන්න එපා. units වලින් ආපු questions වලට ඔයාලට උත්තර ලියන්න පුළුවන්, right? Okay, then පුතේ එහෙනම් ඔයාලගේ යාළුවන්ට කියන්න ආපු නැති කට්ටියට මේ recordings ටික බලලා ඊළඟ දවසේ අපේ class එකට join වෙන්න කියලා.